Good afternoon. So my name is Aashish Chandra. I'm with Sears Holdings, and at Sears, my responsibility is to oversee the application modernization. Sears, as many of you may be aware, is a very old company. Been there a long time, 130 years actually, and a lot of applications, really old applications, 30, 40 years old. We have mainframes, just like many other large Fortune 100 enterprises. And my goal is to look at all the applications, rationalize them, modernize, and build a strategy, and then implement the modernization plans. And my secondary job is that while we were doing this, we came up with building some really nifty stuff, built some tools, big data tools. We built technologies, innovated some pioneering work, built products, solutions, and tools that we are patent pending. And we decided to launch our own company called MetaScale. So I'm a general manager for MetaScale, which is a big data startup company. We provide services through MetaScale to organizations, mostly mainstream enterprises, and help them with all kind of big data services, whether it's data architecture, data strategy, consulting, or end-to-end big data Hadoop services, et cetera. So today, I'll be talking about a load of things, but we'll go into some tools as well, where we will show you some of the use cases. We have dozens of use cases, fairly decent and large-size cluster, over 1,100 nodes in our production, in our clusters for Hadoop, the data nodes. And a lot of tools, including Storm, Cassandra, that we use for various kind of use cases at Sears Holdings. I'd like to share with you, see if you can benefit from that knowledge and information. Inside the modern consumer's mind. We'll start with consumer. So in this day and age, right, those days are gone when a consumer will make their decision when they shop in the store. Today, consumer is tech savvy. They have access to all kind of information. They do their shopping with mobile devices, smartphones. They are really intelligent. They have instant access to information. So how does that impact the retailer, right? The expectations of consumer have changed because of that instant access of information. The consumer now expects retailer to be personalizing, real-time, and digital engagement with the consumer. So it's important that a retailer is being able to get to the consumer at the right time with the right promotion. And that's one of the key things that we strongly believe in. And that's helped us go into the transformational journey that we have been under for a few years now. We have to be, all retailers, all mainstream enterprises really, have to be agile, nimble, and adaptable. We just have to be. You don't really have a choice. You either do that or you accept that you're going to not be in business anymore. So some classic enterprise challenges. Organizations who have been there, large enough organizations who have been there for long enough, have sort of similar challenges. We all have data latency issues. We have legacy systems, legacy data architectures. The data is growing pretty significantly. Costs are not going down. The costs are escalating. If you are a mainframe shop, you know exactly what I mean by saying when I say that MIPS cost more, and you have tens of thousands of MIPS in your mainframes, and just not mainframes. It's anything that's proprietary. So we are a huge advocate of open source technologies. Scalability ceilings, lack of agility. We need to be at a place where we can get to making decisions, insight-based retailing, right? Data-driven decisions based on facts, based on numbers. We need to be there and almost be real-time or real-time. We cannot be batch mentality where we are running a mainframe job or whatever batch job we have, whether it's ETL batch or data warehouse batch. We cannot just go on for all-night batch processing and then wait for it to finish to make copies and copies of data and then actually use that information. So the latency is just phenomenal in mainstream enterprises today, including Sears Holdings, of course. The ETL complexity is a challenge, of course, and skills. Legacy skills are not easily available. Anybody who's going to school now doesn't get any kind of skill knowledge in COBOL or JCL. So you have to really think about how do we go from that 40-year-old technology to state-of-the-art technologies and train those people into doing that kind of work. Advanced analytics is the holy grail. You want to get to machine learning. You want to be able to make those really data-driven decisions. But it's not just that. There's a journey to it. You have to think about the governance. You have to think about storage, archiving, refresh. How are you going to ingest? All those different things come into play when you move towards that transitional plan. So Sears Holdings and MetaScale, right? Just for fun's sake, this is one of those mail order catalogs from Sears Holdings, 1897, way before my time, and I think everybody here as well. It just shows you Sears been around, large organization by any measure, and multiple brands. I mean, I can't imagine anybody who's not well aware of Craftsman tools or Kenmore appliances. Lens End. So some very well-known brands that we have grown up with. And what does that mean from big data standpoint at Sears? We are a multi-petabyte shop. We have petabytes of data in our Hadoop clusters, in our enterprise data warehouses. Hundreds of millions of customers, over 15 million requests every day coming in. We have thousands and thousands of production jobs running in our Hadoop cluster alone. I mentioned earlier we have over 1,100 nodes in our Hadoop cluster. And what you would hear me is that how it is so crucial to find what's your enterprise data strategy, what's your vision. You almost have to have that foundation right. It's so critical to ensure, and this is not just because we got lucky. We have earned our scars. We went the wrong way first. We thought, let's go after the shiny ball. Let's do how can we do this? And we were beaten up pretty bad because the technology wouldn't work. It wouldn't scale. So we have been through a lot of challenges. We have been through a lot of scars to get to a place where we now have, we think, a pretty decent recipe that works for the type of needs you have. And I'll show you some of the tools that I cannot go too much in detail, but it's something to percolate on, something to think about, that how can I use Mahout, which is going to help me, Apache Mahout, on top of my Hadoop cluster, do machine learning, use Hadoop for batch processing only. You don't want to use it for interactive workload. And perhaps do the streaming through Storm or Kafka or one of those tools. So we'll talk about that as well. So we do sentiment analysis, of course, which is crucial. Data science, data visualizations, tools are available from Tableau to you name it, you got it. There's so many tools out there. We have a lot of structured and unstructured and semi-structured data. From retailer standpoint, oftentimes, as a technologist, we don't realize how much more structured data is for a mainstream enterprise than it is unstructured. I mean, of course, there's streams of data coming in. It's like the fire hose thing, right? Streams of data coming in from tweets and so on and so forth. But there's also a lot of batch that's happening at a retailer or a financial services company or insurance or bank or healthcare. That happens all night long. So we were just talking about retailers like Target or retailers like Macy's. There's a maintenance that happens. You're sending price changes to every store, and we couldn't send those price changes every day. Did you know last year, during Thanksgiving time, Amazon was changing their prices every hour? Doorbusters were going on, right? So Best Buy is putting, hey, I got this nifty technology gadget that I'm going to put on doorbusters for the next 1.5 hours or so. And you do come into the store, and you'll buy it. The moment Amazon found out, they reduced the prices by 3 cents on their own website. And then Walmart is on the same game, right? So there's so much by hour. It's like an instantaneous, real-time price war going on. And retailers really have to be ahead of the curve. You can't really say, oh, wow, Amazon just reduced the price. Let's change our price and send the price maintenance in 3 days from now. Really? So it's important to get to all those complex queries, yet make them simple to execute. Efficient, be agile, be nimble. So all of those plays come into there. Sentiment analysis includes the feeds coming from Twitter. You want to be able to say that I got this kind of tweets coming in every minute, and I got these users, and I have this whole, using a data visualization tool, I have this specific technology that allows me to say, there is Jane Smith who has 365 followers. I really want to follow her. I want to make sure, because she's influential, I want to make sure I get to convince her and become my brand ambassador. She's active. So how do we analyze the sentiments? How do we persuade our fans or shoppers to become our brand ambassadors, so on and so forth. So all that comes into play, of course. And as we were doing this, we built, as I mentioned earlier, a bunch of tools, big data tools and technologies, and decided to launch a company. We felt that organizations, enterprises, have such a huge opportunity from just being a cost center, which many IT organizations are still, just cost center. They are a budget line item. So when they go to the CFO or the CEO, they say, oh, you're the guy who wants the money, right? So compared to that, how about you become the revenue guy, the revenue rainmaker? You are now generating revenue. You are now bringing money to the table. And that's what we did with MetaScale. We decided to launch our own company based on the tools, the knowledge, the practices we have built, and then sell those services to external customers using that center of excellence knowledge to help with Sears Holdings. So that's what we do from MetaScale standpoint. Legacy icon with antiquated technologies and data architectures, right? So we had issues with meeting production schedules. There were jobs. They would take 18, 20 hours, just running on. And if there's an event in one of those jobs, then you just don't have enough hours in the day to actually fix it. You will just lose the data. You don't really have a choice. That's the way it works, right? How can we have those 18, 20 hours jobs run in 13, 14 minutes? Multiple copies of data, and this is pretty common. We just poor architects sometimes, retailers or enterprises, where we just make multiple copies of data. We had an instance where we were making 26 different copies of same data. Every one of those business users would actually apply their own logic to it in a slightly different fashion, and then use it for their own purposes. And now, if you want to pull or create some kind of a data repository, you're pulling data from all these different sources to get something accomplished. You're trying to do a project. The first thing that you do in a project implementation is the whole data integration piece, making sure you pull the data from the right places. It's eating up so much of your time from implementation standpoint. How could you be agile? The first step of being agile is thinking agile, right? So you have to look at everything. It's the way of life. Look at the way you do projects, the way you think about loading the data. So when you started looking into all those things, the complexity of ETL. So we are now operating under no ETL zone. There is no such thing as ETL, period. It's giving way to ELTTTTT. By that I mean to say you extract, you load, and then you transform it at multiple locations. But you create one enterprise data hub. You make sure the data is coming into one place. Now, that could be Hadoop. That could be combination of Hadoop and, I don't know, Teradata, Astra. Depends on how long you want to hold the data in what tool. You have to use the right tool for the right job, the right time. It's so important because they all come with a specific niche. You have to identify the strength of that tool and use it for that purpose and that purpose alone. Otherwise, you are first not trying enough to find the best strength of the tool, or you are actually not leveraging, or you're spending too much money into a tool which is going to be very expensive because for large organizations, money is not necessarily such an issue. And we see ROI coming in from it. But we heard about scientific organizations who have to depend more on open source per se than spending millions and millions of dollars in very expensive appliances, of course. Latency in data, we had some cases where we had up to weeks of delay. So by the time you generate the data and when you actually use it to make some insight-based decisions, there could be a lapse of hours, days, even weeks. Data warehouses were unable to handle load. Mainframe workload was overconsumed capacity. Every time comes July, August timeframe, you're having a discussion that, hey, we got to buy another mainframe machine, heavy iron. You just can't get rid of it. The capacity is going to grow because the data is growing every day. And you end up spending millions and millions of dollars of adding that capacity back in. How can you use mainframes for its strength? We took out one mainframe machine last year by moving mainframe workload off to Hadoop. We are well on our way to take out another mainframe machine this year. So we are on the journey to shrink our entire architectural plan and use the right tool for the right place. And that's what I think brings the essence of this conversation. And where do we get to? So we want to be targeted, personalized, real-time, and digitally engaged to our consumers. To get there, we need to get to open source. That's some of the principles. Open source, cloud-based. We have one of the services we offer from MetaScale is the private virtual cloud services. And that's because we are over 95% privately virtual cloud at Sears Holdings. Real time, we are killing the batch mentality. The thought process of, let's do a project in Big Bang. That just doesn't exist anymore. You can't take 9 months to go back to business and say, oh, that's a great idea, let me implement it for you. We'll see you next year. You can't do that anymore. You have to be able to deliver something as a proof of concept or a prototype much faster. Reusable and agile technologies and commodity hardware. So those days are gone when you can just depend on only heavy iron or very expensive stuff. Of course, they will be used for them, but use them in the right place so that you're not over-consuming or exploiting your funds. Data strategy is key. Oftentimes, we overlook the importance of the foundation. And what we find when we look into multiple organizations is, and at Sears as well, is that oftentimes it's the foundation that's not right. The architecture, the data architecture put together is not completely thought out. You really have to have a very strong foundation, not only from data architecture, application architecture, the data strategy needs to be really thought out. Because if you're not, you're going to have to come back and fix it. It's just how long further you go in, and you're not really failing fast. You're going to spend a lot of money to learn those lessons and then come back and fix it. We wanted to get to predictive and sentiment analysis. And of course, ultimately, IT as a business, which led way to MetaScale, where you are actually generating revenue for business, not just a cost center. So here's a use case. I just talked about we took out a mainframe machine. How did we take out a mainframe machine? What allowed us to, and this is no joke, guys. I mean, for those of you who have mainframes, know that they're not an easy beast to tackle. It's not for the faint, faint at heart. You're looking at projects that have failed multiple times because of the complexity involved. You're looking at COBOL, JCS, thousands and thousands of lines of code in each program. COBOL, the way it's written, and there are some guys, I'm sure, who have done COBOL programming here. You're looking at 7,000, 8,000 lines of code in COBOL and JCL, which if you want to migrate, and these guys have done programming, so it's not something that the code was written yesterday, 40 years ago. Every time there's a change, next thing you know, they append on top of it. And over time, the source code is gone. Assembler source code is gone. You just lose it over time, right? So how do you actually migrate or modernize that mainframe application and move it to something as new as Hadoop? And how do you train those people who only know how to do coding in COBOL and JCL? What we did was we said, you know what? We want to be disruptive, period. It has to be disruptive. It has to be innovative. Yet, it cannot disrupt the business. So keep the input and keep the output exactly the same. Don't change anything. What you see here is, let's see, this is a pointer. So the sources of data coming in, and then these are the steps of computation, right? And then output goes right there. We don't change anything here. And after the source of data coming, we ingest the data into Hadoop. Right? Now you could use, depending on what kind of data it is, let's say it's coming from DB2, so we are doing DB2 unload process. If you want to try some semi-structured, you can do all kind of things, all kind of tools. You can build some, but why build when you can get something open source or when you can buy something which is already there, right? So we have this data moved into Hadoop, and then output goes back in there. So from the business standpoint, nothing has changed. It's exactly the same. But behind the scenes, this entire process that was consuming, let's say, 13.76 MIPS, in entire process here, right? It's not going to do that. It used to take 13.76 MIPS. It had 7,000 lines of programs of code, each job for COBOL or JCL, let's say. This is going to run, and let's say it also takes 6.5 hours to run the whole job right here, series of jobs. Now, once it moves into Hadoop, you take out the MIPS computation piece, and it's probably going to take the entire job less than 0.5 MIPS, because there's some MIPS consumption here as well, but the real piece is here. Instead of taking 6.5 hours for the whole job, now you're probably taking 11 to 12 minutes to do the Hadoop piece, and half an hour to move in, half an hour to move out. So hour and 15 minutes compared to 6.5 hours. All of a sudden, your batch processing window is shrunk by 20, 30 times. And at the same time, you modernize your code. You wrote your code, which was in COBOL and JCL, 7,000 lines of code, into Pig Latin on Hadoop, which we do. We move it to Pig Latin on Hadoop. We tried multiple things, of course. MapReduce, Ruby on Rails, Hive, even Hive, and eventually settled with Pig. We found Pig is the best when it comes to batch processing on Hadoop. And for the reason is that, much simpler, easier to code, and the code that was 7,000 lines of code is down to 137 lines of code. Much simple to explain and to understand, because there are guys who do development, right? But those are not the same guys who are actually supporting from operations standpoint. You got to make code as simple as possible for the guys who can actually support the application. From that standpoint, we found Pig was really something that worked for us. So it gives you an idea of how we migrated how much was it, 13.76 MIPS? How we migrated a 13.76 MIPS job into 0.47 MIPS. You just saved yourself over 12, 13 MIPS. And each MIP, by the way, how much does it cost? It costs anywhere from $2,000 to $5,000, to some organizations, $8,000 a year. In just one programming code, which could take less than 3 business days to do it, by the way. And then comes the challenge. How do you train those mainframe guys into becoming Pig experts? They don't know what Pig is. They don't know what Hadoop is. Interestingly, we found they were able to pick up Pig really quickly. It's the Linux concept that they were not able to understand. It's the Linux that was a very difficult thing for them. It's really, the Pig was much easier for them to get to, much condensed code, of course. This is our ecosystem. It's derived from what Google and Facebook had put together. You can use any tools. Of course, I talk about Pig over here, HBase. I mean, there's, of course, the master nodes would include Zookeeper nodes, the master, secondary master, tertiary master. You're having the job tracker, all the usual stuff in the Hadoop stack. You're having, as I mentioned earlier, we have over 1,100 nodes in our environment today. But goes back to how do we fit Hadoop ecosystem into our entire data strategy? So let's go into that, because Hadoop is not one-all. Hadoop is really, really good when it comes to batch processing. However, when you go into streaming data, interactive data, things like that, you find Hadoop is just not going to do it for you. So what do you do to put the right tool for the right job? And I can't go too much in detail, but I can share with you some of that. First, talk about augmenting with Hadoop, right? What is Hadoop's strength, and what are its weaknesses? Let's compare that to traditional databases. Let's compare that to something like Oracle or whatever DBMS you can think of. Here, you see that the two scales, the size of data, and we are dealing with petabytes and petabytes of data, of course, and of course, complex analytical queries. And as you go and make the complex queries in, you would find that they'll start losing steam. Some of the traditional databases, because the data size is so huge, when you're talking about the scale of petabytes, it just can't take it anymore. So that's where it talks about the data size grows. They are really, really good, very fast, microsecond response, millisecond response. But when you get into really, really large and complex queries, you find that Hadoop actually plays a really good role. It won't give you microsecond or millisecond response. There's data latency that comes with it. So you use Hadoop in really large, complex data sets, batch processing. When you got 15 billion lines of records, that's how many records you got in your code. You run it through Hadoop. It's going to take 12, 13 minutes to do it for you. So that makes a big difference compared to hours and hours. The clock time will just stop. You'll run out of the measuring time because in something like here, it's just going to keep going on. It won't be able to take it. Hadoop is inefficient for small data sets, but is designed to handle big and complex data. Hadoop can keep, so the whole strategy for archiving is just completely gone for us. We don't even use disk tapes or any other kind of archiving system. Hadoop does it for us. We just load everything in Hadoop. We don't have to lose data anymore. We couldn't hold data. It was so much data. We didn't have systems that would allow us to hold data for longer than 3 years or 2 years, depending on what kind of data it was. Now we can hold on to it forever, because that's key. That's inside information that you want to not lose at any cost. We hold on to it because of Hadoop now. And not only do you hold on to it, you can almost perform near real-time queries on it. You don't have to load the disk tape back in there and then go through the whole process, cranking through the stuff, and then do the queries on it. It's accessible for you right there. OK, so the data strategy, right? The way I classified it is I wanted to keep meaningful information in the tools, their strengths, so you could benefit from it. At the same time, not give away too much about how we do some of our proprietary work. So two scales here. One is, what is the function from the data standpoint? You're looking at acquisition. You're looking at, you got transformation, persistence. Of course, you know all the functions all the way through machine learning, right? Because at some point, the scale of human being able to apply the intelligence is just not going to meet your needs. You're going to have so much intelligence, so much to do that humans just can't handle with it. So you use machines for it with machine learning, right? And then the second scale is, what is your service level? What is the expectation? That's a key thing. For some organizations, let's compare eBay. They need to be able to respond in microseconds. They just have to. So would it make sense for them to depend entirely on Hadoop? It does not. I mean, yeah, Hadoop for some things, but they need something that's going to work much, much faster. There are people bidding on things. There are things that are going really interactive. Compare that to mainframes, right? You have bad job running, and it's taking 22 hours right now. You can do the same thing in 2 hours and 14 minutes. So yeah, you're going 10, 20, 50, 100 times faster. Hadoop is absolutely the right solution for that. So you have to look for different use cases. And I will share with you at least half a dozen use cases, how we are using these technologies today inside our Sears shop on the next slide. However, what you really have to think about is what tool to use for what job and what organization, because your business might not require microsecond or millisecond response for certain specific functions. Point of sale data is very important for us. It's streaming coming in. You want to be able to crank through that data and make immediate decisions. I want to be able to know in last 5 minutes how many these new branded shoes I sold and make a decision based on that, based on alerts that I get, instead of a reporting mechanism which is going to take weeks to get, right? We just heard about that from our previous conversation. So here's my scale, and here's the set of tools. And I did not give you all the tools here. I did not share all the big data tools that are out available. There's so many of them. It's unbelievable. But it gives you something to think about in terms of if you have a point of sale data, you're pulling the data in and versus the batch data. Then point of sale data, it makes a lot of sense for us to run it through Storm or Kafka. And then you load it into Cassandra. Hadoop can store for archiving purposes and for long-term retention. But Cassandra can help you with real-time processing. Storm can help you with transformation. It also helps you real-time streaming processing as well. So it really depends on what kind of a service level is your expected time frame is. You could use the entire open source stack with tools such as, I'm thinking about the open source stack. If your service level is not microsecond or milliseconds or even seconds, right? You can go with something completely open source in a stack standpoint with Hadoop, Mahout sitting on top of Hadoop. It really sits right on top. And you almost got yourself an entire stack for free. Commodity hardware. You can buy those machines for really, really cheap. One of the use cases we did last year with ETL modernization, right? We are no ETL zone. So we had, again, August timeframe, and we are at a time where we need to buy a bunch of licensing. It's going to cost multi-million dollars just to renew or just to get additional licenses for the holiday growth. We know it's going to come. We just don't want to spend the money. So we had, of course, the budget that came up and said that we need to spend that money. And so I'm going into use cases now, right? So one of the things we had was in the we don't want to spend the money. In 13 weeks, we were able to move all that workload, ETL workload, into Hadoop. It was going to done much faster. We were able to take the batch on ETL, several hours into a few minutes. It was much cheaper. I mean, the budget was several $1 million. It was done in less than $50,000. So how do you monetize it, right? When you build, when you innovate, you have to look at what does that mean? You just don't want to be a technologist. You want to be a businessman. You want to be able to see how a product is going to make money for you. That was one of the key criteria for us. How are we using Hadoop? How is it going to save real dollars, the green dollars, right? So some of the use cases here talks about mainframe migration, talked about that. ETL modernization, sourcing once, reusing the data multiple times. You don't want to keep making copies and copies of data. Intelligent archive, we talked about that. Data latency, you don't really need to live with that anymore. There are technologies and tools available in mainstream enterprises. I'm not talking about technology companies, Facebook, Google, et cetera. Of course, they don't have 50-year-old mainframe systems to legacy or to live with, right? So they can be on that, but from mainstream enterprises standpoint, we have that 40-year-old mainframe machine that's just heavy iron cranking on it, right? Streaming Twitter feed analysis, we talked about that as well, where we look into the sentiment analysis and we based on the follower base. Pharmaceutical predictive analytics. So this goes into being able to do predictive analytics where you can make recommendations. So Mahout is really good with that too, right? You can actually look into your pharmacies, Kmart pharmacy. I know that Jeff comes there every week and or every once in a month, on 30th of the month or whatever date you pick, but he stopped coming, or he buys products for prescriptions with diabetes, right? California. So with that, we know that there are other prescriptions he can get from us as well, but he's not getting it. So what does that mean? What all can I sell him? What can I understand from his shopping behavior? What can I know about that person? So creating the entire profile of the consumer and really making a targeted, digital, real-time, and the right timing interaction with them. Offer them, hey, come to our stores in the next 2 days, and we have a special promotion going on for you because you haven't bought your jeans in the last 9 months. For next 2 days, buy that from us. Those kind of promotions. So guiding principles. So time's up, so I'm going to take just a couple more minutes, guys. This is a slide before one. Thanks. Some of the innovation principles, including making innovation part of your DNA. Everyone is an innovator. You don't have to have a special fabric in you to be an innovator. Every one of us is an innovator. We just have to find the right mix, right? Fail fast and fail cheap. A businessman first, technology second, may not be a very popular phrase right now in this audience. Agility as a way of life. No big bang implementations. Measure the innovations. Unless you measure it, you don't know. So how many patents have you filed? How many products are we creating? Can we monetize from those products? Can we productize from that IP? So it goes in series of steps. So you create an IP, you productize it. You monetize it. You create a patent application through process with it. From data strategy standpoint, design for the unknown. You really don't know what's going to be tomorrow. It's just, there's going to be so much new coming up. So you really have to build your engines for what could be tomorrow. Make it simple, reliable, rescalable. Source data once and reuse. Parallel processing, no longer time of linear processing, of course. Cloud-based and open source. Real-time, commodity hardware, no ETL zone, and time to market is everything. So I'll end with this slide. Some tidbits to think about from if you are re-architecturing your data architectures or strategy. You really have to think about all these things. And with that, thank you very much.
Thank you.
Thanks.